Welcome to Peterbilt's latest body integration training. My name is Tony Sabler. I am Peterbilt's Vocational Marketing Manager, and I am glad that you have joined us. This particular training module is part of a series. It will highlight the benefits that a common electrical architecture provides, including dedicated connectors for consistent body integration. We'll look at the various types, where they're located, and what they can be used for, and why it is so important to properly spec the truck with the right connectors. Once you're done, I invite you to view the rest of the 2021 Body Integration Series. The first major benefit relates to the consistency of body integration across Peterbilt's trucks. For those of you that are familiar with a prior VECU system on the 567, this will be very familiar. In general, all of our models will be using the same connectors, available in the same locations, and provide the same functions. When considering the chassis to body connections, you need to know what type of communication is needed. Will it be hardwired connections or CAN-based J1939 communication? Both are available and conveniently located with VMUX. And if you need more technical information, I recommend viewing our online resources for the latest bodybuilder manuals and programming guides. Let's look at some of the more common connectors that are used. I'll begin with the remote station throttle controls. What is a remote station? It's any PTO control location other than the dash and steering wheel controls. One not so obvious example is a body controls module mounted inside the cab. There are two primary communication options: hardwired connections like the 12-pin and 8-pin connectors, or CAN bus communication, typically called J1939. One point to note, for J1939, be sure to designate the correct kilobaud or communication speed for these body controls. There's also an RP1226 connector inside the cab for CAN connections, and it includes both kilobaud speeds. These must be spec'd when the truck is ordered. They're very time-consuming to retrofit, so I highly recommend, if the truck might need remote throttle controls, spec it up front. The 12-pin and J1939 CAN bus connectors are what the bodybuilders can use to communicate throttle commands from a remote station to the engine. The 12-pin is what's considered a hardwired connection, which means the bodybuilder will use individual wires for each signal they want to send. J1939 is part of the CAN bus, and some bodybuilders choose to use that single wire where they can send multiple messages using J1939 codes. Which type of connector is needed depends on what type of communication the body manufacturer uses. There are 3 locations available, depending on what is most convenient for the integrator: the engine bay, where you have the 12-pin only; the back of cab, back of sleeper, where you have the 12-pin and J1939 connectors; or the end of frame, again with the 12-pin and J1939. The 520 is unique, since the engine bay and back of cab location are very close to one another. Selecting either the engine bay or back of cab location for the 12-pin will put the 12-pin remote throttle connector halfway back the right-hand rail. As with other models, the engine bay location will not include a J1939 connector with a 12-pin, so select the back of cab location if you need CAN bus communication. The end of frame location also provides both J1939 and the 12-pin connections. Here you see the pin-out functions for the 12-pin remote throttle connector. There are 2 versions, depending on which engine is in the truck. The 2021 Bodybuilder Manual, available at Peterbilt.com, includes descriptions for how to connect various pins for functions like activating PTO mode control or changing engine speed. One change to be familiar with, in comparison to the prior VMUX system on the 567 with an MX engine, is pin 11. It used to be 12-volt, 20-amp engine power. It is now 12-volt, 10-amp ignition power. So what sales codes do you select? It depends on where you want the connector, and if you need CAN bus communication, what kilobaud speed, 250K or 500K. This information comes from working with the body integrator. And be sure, for J1939 communication, select the correct CAN bus speed. We also offer another remote throttle connection that provides advanced PTO features specifically for the MX engine. This is an 8-pin hardwired connection that enables pre-programmed PTO speed requests from the remote station. It provides a high level of customization to make PTO speed requests easier for the operator. You can select up to 3 remote station preset PTO speeds in addition to the 3 preset PTO speed switches that are available in the dash, for a total of 6 preset PTO speeds on the truck. This offers industry-leading flexibility. They can be programmed to work as a toggle or dedicated switch, and with latching or momentary functionality. The 8-pin connector also includes the ability to provide a signal for a customer-installed safety interlock, like a pedal on the back of a rear loader. Just like the 12-pin, this harness must be spec'd with the truck. The 8-pin connectors are available in the same 3 locations as the 12-pin remote throttle harness: in the engine bay, at the back of cab, or end of frame. And when it is spec'd, will always be tied to the location of the 12-pin harness, so the 2 are routed together. As you can see on the pinout table, you have power and ground along with pre-programmed PTO speed settings for the remote station, which, as I mentioned earlier, can be different from the preset speed settings for the cab station. And pin 2 is used for a customer-installed safety interlock signal. So what sales codes do you select? Again, this functionality is only available on the MX engine. The only options are related to the location, and as I mentioned earlier, the location is always tied to the 12-pin connector. The 4-pin is available for PTO controls that are electrically engaged using a ground signal for confirmation. This is a standard on the harness and is not represented as an option code on the spec. You'll also notice that it does accommodate 2 PTOs. Most truck models include a PTO pump mode signal option, primarily for use if you want to declutch the drive axles when a split shaft PTO is engaged. This simply shows that the 4-pin connector for PTO feedback is located near the top of the transmission. This 14-pin connector is specific to the models 535, 536, 537, and 548, and provides the basic body lighting functions that are so common in the medium-duty market. It is an ideal replacement for the Berg lighting junction box that has been used in the past. As I just mentioned, the heavy-duty models continue to provide the basic body lighting junction box. It is located in the frame rail, either at the back of cab or end of frame, depending upon where you select. There are 2 options for this, one with wiring and one without. Be careful to select the correct option. The new medium duty introduces a full height frame rail option for snowplows, and many 567s are also being upfit for plow applications. Both models offer a snowplow lighting option that provides a switch on the dash to control the plow lights and a convenient 14-pin connector at the front of the chassis. Next, we'll focus specifically on the Model 520. The refuse industry developed a TMC RP170 specification for common connectors. It includes 3 connectors, one on the outside of the cab, just like the 14-pin connector we just discussed on the new medium duty, and it provides the same body lighting functions. The other 2 connectors are inside the cab. One is an 8-pin for various power and ground connections, and the other is a 31-pin for all the other functions that are shown here. These connectors are standard on every 520. And here you can see where these connectors are located on the 520. Again, what sales codes do you select for these options? Here's a summary of the body lighting connections and snowplow lighting. Note that the model 520RP170 connectors are not listed here, again, since they are standard. The final hardwired engine control connectors that I will briefly touch on are dual station controls. When spec'd, these provide additional controls from a remote station outside of the cab. They are different from the remote station controls that we covered earlier and are primarily used in oil field applications or on cranes that have a dedicated operating station. The option will either include a 16-way connector or a 23-way connector, depending on the engine. Remembering back to the beginning, I mentioned that there are two primary types of communication, hardwired and CAN-based. The connectors we've covered so far have been hardwired connections. The only exception is the J1939 connector that was paired with the 12-pin remote throttle connectors. Now, we will take a look at CAN-based communication methods using the RP1226 connector. Telematics, ELDs, in-cab body controls, and PTO controls are some of the primary uses for this one. We are seeing a lot of bodybuilders opting to use the RP1226. It is a consistent integration connector across the industry, so it simplifies the body manufacturing process. A single RP1226 has been available on the 579 and 567 for nearly 3 years. With the implementation of VMUX, many of the truck models now have a second RP1226 connector as standard due to the increasing popularity with aftermarket devices. The general locations for these are consistent across the models, and I will show you in a little more detail next. I'll also point out that the RP1226 includes both the 250 kilobaud and 500 kilobaud communication speeds, which is helpful in comparison to the 12-pin remote throttle connections where you have to spec the correct speed. Here we have our 2.1 meter cab platforms for the medium duty and the heavy duty 567 and 579. Following the general location philosophy, the first RP1226 connector is located on the left-hand side, near the OBD port. The medium duty has one connector as standard. On the heavy duty, the second standard RP1226 connector is located near the passenger side footwell, convenient for telematics displays or in-cab body controls. And for the 1.9 meter Model 389, the locations are very similar to what we just saw on the 567. And on the 520, the first connector is located in the center console, along with all the other body integration connectors. The location of the second connector depends upon the cab configuration. For left-hand drive and both dual drive cab configurations, you'll have it on the left-hand side. For the right-hand only cab configuration, we put it on the right-hand side. This brings us to the end of this body integration module focused on connectors. As you can see, Peterbilt provides dedicated connectors for the body operations that you need. A major benefit is the commonality that we have implemented across our truck models. They are conveniently located, and using these will improve consistency and reliability for the customer. We have learned about two main types, hardwired and CAN-based, with examples of each. Be sure to include these on the truck specs that you're working on. In addition, Peterbilt has many online resources that you can access. At peterbilt.com, select Bodybuilder Resources from the drop-down menu for the latest bodybuilder manuals, operators manuals, and product literature. It also has a link to Peterbilt's YouTube channel. Go to the Bodybuilder Resources channel to view more videos. More importantly, subscribe to the Bodybuilder Resources channel so that you receive updates when new videos are posted. Next is the Peterbilt OneSource for literature, product guides, and videos. Then Packard.net, which replaces ePortal and DealerNet. This is a great location for technical information. And finally, PackardPowertrain.com for information about Packard engines, axles, and transmissions. This module has just scratched the surface of information that you want and need to know. For more information, be sure to watch the additional Peterbilt body integration modules, which dive deeper into each one of these important topics. I hope you have enjoyed this module on 2021 VMUX connectors, and I look forward to our next opportunity to work together. Thank you.